Okay, Lewis dot diagrams are a way of representing how different atoms bond with each other. If you remember, we drew all these layers of electrons, but the thing is, only the electrons on the outside are involved in bonding. So Lewis diagrams only show outside layer of the outside layer, the outer layer of electrons are called valence electrons. So we only show the outside layer, and the outside layer is called the valence electrons. So we're showing the valence electrons that go around each of these elements. So like we saw before, what happens is that chlorine steals this electron here and puts it right there. So now chloride has 8 electrons around it. That means its shell's full and it's happy. And although it looks like sodium doesn't have any, what really happens is that below that valence layer we've got a full shell. So it's actually pretty happy. How do you know how many valence electrons that elements have? Well, you can tell just by looking at the periodic table. We're going to deal with these guys here in the transition bridge. We're only going to deal with the ones on the outside. Well, hydrogen has 1. Helium has 2. So look, that shell's full. So we're going to start another layer. Lithium has 1. Beryllium has 2. Boron has 3. How many do you think carbon has? 1, 2, 3, 4. Nitrogen, 1, 2, 3, 4, and then we add another one, a 6th one. Notice how I put 1 dot on each side before I start pairing them together. Oxygen has 6. 1, 2, 3, 4, 5, 6. Fluorine, 1, 2, 3, 4, 5, 6, 7. That's got an open one there. So neon must have 10. 1, 2, 3, 4, 5, 6, 7, 8. Oh, I'm sorry. Yeah, it must have 8. So 8, this fills up that layer. So we got to start a new layer. New layer starts with sodium, 1. Then magnesium, 1, 2. Then aluminum, 1, 2, 3. Silicon, 1, 2, 3, 4. Phosphorus, 1, 2, 3, 4, 5. Sulfur, 1, 2, 3, 4, 5, 6. Chlorine, 1, 2, 3, 4, 5, 6, 7. And then argon, 1, 2, 3, 4, 5, 6, 7, 8. It's got a layer of 8. We've got to start a new one. Now, you probably noticed by now that in column 1 we have 1 electron. In column 2 we have 2 electrons. In column 13, which ends with a 3, we've got 3 electrons. Column 4, 4 electrons. Column 15 has 5 electrons, 1, 2, 3, 4, 5. Column 16, 1, 2, 3, 4, 5, 6. All of them in the same column have the same number of valence electrons. So we can then determine the number of valence electrons by looking at the column of the periodic table that element comes in. So let's just draw in the rest just to show it still works. And krypton has 8, so it's full. It doesn't bond with anything either. So how do we use the Lewis dot diagrams? Well, we can figure out how things will bond simply by looking at the Lewis diagram. Let's take a piece of paper here so I don't bleed through the other pages. So if we look at potassium, we see that potassium has 1 right here. Bromine has 7 valence electrons. So 1, 2, 3, 4, 5, 6, 7. Well, how do they get together? Well, what happens is that the bromine steals this one from the potassium, and what we get is we get our positive potassium and our negative bromine, and what happens is that since this guy's full, they then get attracted to each other. Let's take a look at magnesium. Magnesium has 2. Oxygen has 6. So what happens is the oxygen takes this electron, puts it here, takes this electron, and puts it in here. But since it took 2 electrons, it's now got a 2 minuses. Now this guy lost 2 electrons, so it becomes 2 plus. So 2 plus and the 2 minus come together. One, 2, 3, 4, 5, 6, 7, 8. So oxygen's got a full shell, and magnesium's got a shell below it that's full. Well, why don't you do calcium and chlorine? Just pause the tape, pause the film, and try it yourself, and I'll give you the answer. I said pause it. Pause it now. Okay. All right, so if you got this figured out, you saw that if you went to the table, calcium has 2, so you put your 2 in there. Chlorine has 7. 1, 2, 3, 4, 5, 6, 7. Oh, this one's a little bit tricky. So chlorine steals one of these to fill its shell, so it becomes a minus. But there's still an electron here hanging out that's available for another chlorine to take. So this one goes over here and fills in this spot. So now what we have is we have calcium. It's lost 2 electrons, so it becomes double positive. And we've got 2 minuses. So together that makes a chlorine. 2 chlorines with full shells, each with a minus sign. And that formula then becomes CaCl2. This 2 shows we got 2 chlorines. This guy becomes MgO, and this guy becomes potassium bromide. Let's take a look at sodium. Sodium has 1 in it because it's in the first column here. Sulfur is over here. It's in column 16, so it's got 6. 1, 2, 3, 4, 5, 6. Oh, sorry. 5, 6. It can steal this electron to fill in here, but it's still missing one down there. So what we need is another sodium. This guy became positive, this guy becomes negative, and so it steals the electron to put it in here, so now it's a double negative. So the sodium, the sulfur, is in the middle, 2 negative, and the sodium are on the outside. And what that yields is a formula that has got 2 NAs and 1 sulfur. So that's how we draw Lewis diagrams for ionic compounds.